Get ready to enter a brave new world with your host, Vasant Dhar.
Brave New World is supported by the Center for Data Science, or CDS, at NYU. If your organization is interested in engaging with CDS through student projects, please email cdsindustry@nyu.edu. For more color on the podcast and additional commentary, please subscribe to my newsletter at vasantdhar.substack.com. Hello, and welcome to Brave New World. My guest today is Anil Seth, who is a professor of cognitive and computational neuroscience at the University of Sussex. Anil is also author of the book Being You, A New Science of Consciousness. Anil, welcome to Brave New World. I'm truly delighted to have you on the show.
Oh, thanks for having me. I'm very happy to be here.
So let's start by, you telling us a little bit about yourself, where you grew up, what influenced you growing up, and that kind of stuff.
Well, so I grew up in a small village in South Oxfordshire in England, sort of very green and pastoral part of the country. And my mum's from the north of England. My dad's from India. I actually just got back from a trip to India, and I still have family there, which I still really treasure.
Where in India?
Well, it used to be called Allahabad, but now it's called Prayagraj.
I wasn't aware of that, actually.
It's a town in Uttar Pradesh. Actually, it's many of my family is still there, but it's also the place where every year they have this festival called the Kumbh Mela. Yeah. And this year, 2025, was a very special one. It was a once in 12 year, in fact, a once in 144 year event where so many people go, and with the objective of taking a dip in the Ganges, or rather where the Ganges and another river, the Yamuna, meet. And it's the number. I was there on the last of the main bathing days, called Snans. But over the course of 45 days, there was something like more than 600 million people went to this festival, which is just extraordinary. Only in India, right? Only in India.
Indeed, only in India. I'm actually amazed. So did you go for that, or did you just happen to be there and it was happening?
No, well, I was there. It was one of those things where I accepted an invitation to go to India, in part because it was around the same time, so I could then combine it with a trip to see my family and a visit to the Mela, which is actually the third time I've been to the 12-year cycle. It changes you a little bit. I can totally identify with that. But I'm sorry I interrupted you. But you were saying I interrupted
yourself.
myself.
Yeah.
I got diverted into the recent trip to India. But so I grew up in England, very different. You won't find 600 million people in these small villages in South England. But I suppose I've always been interested in the nature of consciousness. I think many people are. When they're young, it's the kind of conversation you have at school with friends in the pub. But I've sort of stayed interested in it, and since I was a student in the 1990s, I've been working my way towards that problem from many different angles, trying to understand how and why it is that we are more than complicated objects. We have conscious experiences. We have experiences of the world around us, and we have experiences of being a self within that world. These have been some of the oldest questions in philosophy and science, and different cultural traditions have approached these questions in different ways. And it's been very exciting that over the last 30 years or so, there's been a resumption of this question of consciousness within science quite broadly. It's regained a kind of legitimacy and momentum, and it's been very exciting to be part of that.
And why do you think that's happened? Why do you think it's gained momentum? Is it because, as is the case in, several other disciplines, better instrumentation, that we can actually look inside the brain as opposed to just theorize and philosophize? Has that been one of the driving factors?
Absolutely. I think that's an important part of it. Consciousness philosophically is this big mystery. It's hard to even know what an answer would look like. But compared to some of the other big scientific challenges, like what happened at the start of the universe, or what does quantum mechanics even mean, and brains are actually quite accessible. We all have one. They're relatively human-sized. And you're right, there are these new technologies that allow us access. Now, it's quite poor access in terms of the rich complexity of the brain, but nonetheless, it is now possible, and has been since the 90s or shortly before, to look inside living human brains and brains of other creatures while they have conscious experiences, or while consciousness goes away in sleep or anesthesia. So yeah, we can get data. I think that was a big part of it. You give someone a tool, you give someone a method, and then it becomes much more plausible to use it. But there were also other reasons. I think part of it was just the importance of the question never went away, and it became recognized as not just a big existential question, who are we and why are we conscious, but something that had increasing practical significance in all sorts of segments of society. Like, how do we understand brain injuries that lead to changes in consciousness? How do we predict when people will recover consciousness? What do we do about psychiatric illness? What can we say about animal welfare? Or even now, of course, many questions about AI. Is AI not only intelligent, but also conscious? These things have a great current timeliness.
Yeah, indeed. By the way, I really enjoyed reading your book, and I thoroughly enjoyed your TED Talk as well. Very entertaining, really well done. So congratulations on that. But I want to start with where your book starts, which is you talk about your brain being filled with anesthetic and the whole thing of general anesthesia. And that has a special sort of meaning to me because my mother actually died from a leg injury because she never came out of general anesthesia. And this was in the early 70s in India, at a time when they weren't monitoring your brain at the time, they were doing all of this stuff. So it was relatively low tech. Before our conversation, I actually went to ChatGPT and I asked it, how many people don't come out of general anesthesia? And it said it's exceedingly rare. 1 in 100,000, 1 in 200,000. So, it sort of struck a chord with me that you started your book with that experience. So tell us more about that. What actually happens, under general anesthesia and, what happens to consciousness?
Well, I'm sorry to hear about your mother. That's a tragedy. And you're right. It's very rare. I mean, I suppose that's a good thing in general. We shouldn't be too worried these days about having general anesthesia because, as you mentioned, the ability to monitor anesthetic depth and so on is much better these days. But yes, what happens? Well, I think you can answer that on two levels. There's what happens subjectively to my or anyone's experience in the moment, and then there's what happens in the brain. And I think what really struck me on my experiences of general anesthesia was how different it is from going to sleep. When you fall asleep, there's often some sort of experience still happening. Now, there may be periods where you're completely without experience, but there are dreams and there are other mental contents that happen now and again. But when you wake up from being asleep, you're always aware that some time has passed. Maybe you're in a different state, maybe you don't know how long, maybe you're jet lagged, but some amount of time has passed. Anesthesia is not like that at all. In anesthesia, you're gone, and then, again, for the vast majority of people, you're back, and no time at all seems to have passed. You're just gone and back. And that is super interesting because what's happening in the middle? There's objective time has gone by, all the time where you were under surgery and being operated on. I mean, objective time is ticking by, but subjectively, nothing. And it's not just you experience periods of nothingness. There is no experience. It's the difference between the experience of absence and the absence of experience. So this is amazing. It's almost the closest you can get, I think, to not existing, right? Subjectively, you just don't exist at these times. Consciousness is switched off, reversibly, usually. So that, to me, just indicates, okay, so what is consciousness? Well, it's what goes away in this condition. It's the opposite of general anesthesia. And so there's a wonderful opportunity here to understand what consciousness is, both subjectively and objectively, because now we can look inside the brain and see what happens when people go under general anesthesia and what happens when they come around from it again.
So what happens? And actually, I had an associated question, which was, when was general anesthesia discovered?
Oh, that's a good question. I believe it was a sort of late 19th century into early 20th century invention, if you want to call it an invention. And it came in stages. I mean, there were sort of early anesthetics like chloroform that have been superseded by modern anesthetics. Now we use substances like propofol and midazolam. Also ketamine, which is a bit safer. It's not strictly an anesthetic like the others. There are some amazing stories about the early researchers in anesthesia who, in those days, over 100 years ago, did a lot of self-experimentation, which is both incredibly brave and rather silly, because these compounds can be dangerous if you get the dosage wrong. But yeah, whenever someone asks me, when in history would you like to be alive, if not now? You can think about, wouldn't it be wonderful to be, I don't know, in Renaissance Europe or something like that? But then I always think, hold on a minute, they didn't have general anesthesia in those days. I'm not so sure I'd want to be around then. It's a great thing to know that it exists. And so what happens in the brain? Well, it's one of the challenges is many things happen. So general anesthesia, on the one hand, is a fantastic manipulation of consciousness because it takes it away completely. But it is not a selective manipulation of consciousness. Many things in the brain change under general anesthesia. And so one challenge is trying to figure out which of those changes has specifically to do with losing consciousness and which of those changes are, if you like, just auxiliary effects, indirect effects, other effects of the anesthetic. And the closest, I think, that people have come so far, and this is not my own work, it's work from people like Marcello Massimini in Milan, is that different parts of the brain stop talking to each other in the rich ways that they do in waking states. So the brain is still active, but it seems less, or at least we can say differently functionally connected one part to the other. Now, there are states of anesthesia, very deep states, where you can almost stop brain activity altogether, bring it to what people call an isoelectric state, flatlining basically, but you can still come back from that too. That is a very deep state of anesthesia. As far as I'm aware, most of the time in surgery, you don't go that deep.
So it's a complete lack of communication among the different parts of the brain. You're saying that is normal during normal, functioning.
Yeah, that's one window into it. Of course, maybe not a complete lack, but the real challenge, the frontier challenge here, is to just get more precise about that. And you speak about tools, and of course, this depends on not only the tools we have for measuring brain activity, which are available but fairly crude, in terms of the numbers of neurons you can look at and so on, and the mathematical tools to characterize what's happening in the brain. The challenge for the brain is the complexity of it.
Yeah, so I was going to ask you, how do you actually observe something like this? What kinds of tools do you use to observe that different parts of the brain have stopped talking to each other?
So two kinds of tools. Firstly, you need a, if you like, a physical tool, a measurement device to actually record brain activity in some way or another. And you need, I think, also well described as tools, you need mathematical tools to take the activity patterns that you record and make sense of them. To me, both of these things count as tools. On the first side of things, the physical tools, well, we have all the paraphernalia of modern brain imaging these days. You can put people in fMRI scanners, in EEG or MEG scanners. You can, if they're candidates for brain surgery, they might actually have electrodes implanted inside their heads. So you can measure brain activity in various ways, but you'll only ever get like a fairly crude view of what's going on. And if you think about an adult human brain, there are roughly 86 billion neurons all doing their thing. There's just no way. We just don't have the technology to record in the resolution and both in time and space to give a comprehensive picture of what's happening in the brain. But we can do something, and that's fine. It's a starting point. And the second thing is, given some activity that we record, how do we make sense of it? And those are these mathematical tools that we can use to characterize what does it mean to say one part of the brain is speaking to another? What does it mean to say that there's a sort of emergent global property to the brain activity that's present in some states but not in others? It's a combination of these two things.
But you can actually tell that one part of the brain is talking to another or not, that there's actually a communication happening, let's say, between the cortex and the amygdala or the thalamus. That's something I assume you're able to observe?
Yes, you have to infer it. You can't directly observe it. It's not there in the same way that you might count the number of neurons in a dish. So you use statistical tools to basically infer whether there's information flow from one brain region to another. And there's all sorts of assumptions that go along with that. So it's a little bit more indirect, but yes, you can do it given some assumptions.
So Anil, let's step back a little bit and just sort of come back to your book. And I'd like you to summarize what your basic theory is that you propose about consciousness.
Well, I always feel a little uncomfortable at this because I don't think it's a theory in the way people often want theories to be, which is like here's the answer, or here are the necessary and sufficient conditions, and if you do this, you have consciousness, and if you don't, you don't. I don't think we're there yet with consciousness, with either my own thoughts about it or any theory, to be honest. But we are making progress, and the ideas that I find most compelling and that inherit from much previous work as well go a little bit like this. And it's really the idea of thinking of the brain as a prediction machine. Why? Well, if you think about what brains are in the business of doing, they're trying to keep the body alive, and they try to do this by perceiving the state of the world and the body. The brain is locked away inside the skull. It has no direct access to what's in the world or in the body. So it has to infer the state of the world or the body, much like we were saying just now about how we infer whether one brain region is talking to another. The brain also has a statistical problem to solve. It has to figure out what's going on in the world and the body on the basis of ambiguous, uncertain, and unlabeled sensory electrical signals. And the idea about how it does this, and this is an idea, it's not mine, it's called predictive coding or predictive processing, is that the brain is continually making predictions about what's out there in the world or in here in the body, and using sensory signals to update these predictions to keep them tied to the world or the body. And then the key claim, which I make and which we're testing in various ways or trying to, is that what we consciously perceive is not a readout of the world and the body in this kind of outside-in direction, as if the brain sort of opens itself to the world and the world just pours itself into the brain through the eyes and the ears. No, what we consciously experience comes as much, if not more, from the inside out. It's the brain's best guess of the causes of sensory signals. And my overall idea is that every kind of conscious experience we have, whether it's the taste of coffee in the morning, the sight of a sunset, the feeling of pain or pleasure, a belief, a thought, a feeling of agency or free will even, all of these things can be understood as forms of perception that are in turn grounded on the brain making and updating predictions. That's the main hypothesis.
So I like that framing, and I think you also say that its goal is to minimize surprise.
That's right. So if it, and this gets a little more into the weeds, but not too badly. So if we think about the brain trying to infer the state of the world and the body, one way of doing this is to make and update these predictions. And what does that mean? It means that the sensory signals that come in to the brain aren't read out, but they're interpreted as prediction errors. They report the difference or signal the difference between what the brain expects and what it gets. So it's a kind of surprise. It's a statistical notion of surprise rather than a psychological notion of surprise. And the idea is that if the brain follows a very simple rule, which is to always try to minimize the surprise or the prediction error, then its best guesses will settle on, they'll be very useful. They'll be almost optimal best guesses about what's going on in the world or the body. So this is really appealing because there's a single principle that can be rolled out in many different domains of what brains do, and that can underpin a rich variety of kinds of perception and cognition and action. But there's also this deep simplicity to it, which is the brain is always ultimately trying to do this one thing, just minimize the surprisingness of the sensory signals that it gets.
And this isn't just you, but sort of one of the views is that it has an expectation of what it's seeing. And so if I'm looking at a field, I assume the grass is green, even if the grass is blue or red, until such time that it strikes me that it's sort of, I guess, a prediction error, right? That at some point my machinery tells me actually objectively it's seeing red, but it might have taken me some time to tumble to that because I was expecting green.
Yeah, that's right. And it's not just that you as a person were expecting green. It might be your visual system is expecting green. You don't have to, you as a person have no need to be aware of what your brain is doing. You just see the color. You see a green field or a blue field or whatever. So all these expectations, beliefs, surprises, predictions, they're all happening under the hood. The psychologist and physicist Hermann von Helmholtz, again, a Victorian figure, brilliant figure, was the first person to apply these ideas to perception. And he called it unconscious inference, I think, to make the point that we as people, as individuals, are not aware of all this statistical acrobatics happening inside our brains. We're only consciously aware of the outcome. Either we see a green field or a blue field. And you're right, this happens all the time. If you look up into the sky and it's like little white fluffy clouds, sometimes we see faces in the clouds. If you're expecting to see a friend, in a cafe, and you might actually see your friend, and then as you get closer, you realize it's somebody else. Your expectations have dominated the sensory data for a while. So I think there are lots of examples which reveal that something like this is in fact what's happening under the hood. And of course, in the lab, we can really dig into it and show that this is what is happening in a more substantive way.
As I listen to you, I'm sort of becoming aware of that maybe there's a very arbitrary boundary between things that are unconsciously going on and things that are conscious. Like how do you think about it? Is there a sharp line, or do those things have a very murky kind of boundary?
Oh, it's murky. It's definitely murky. And it's been one of the main questions that people ask experimentally who work on consciousness is what's the difference between conscious perception and unconscious perception? It seems that, well, firstly, there's a lot of things that happen in the brain that we're not conscious of. In fact, we're very rarely conscious of anything that happens in our brains. We're conscious of what brains do, not what they are. I mean, I wouldn't even know that we have no direct experience of neurons, yet our brains are full of them, right? But some of the things that brains do, we may not be conscious of either. So there's this big debate in the field about whether unconscious perception is possible. For instance, if I have a screen, I flash an image in that screen very, very briefly, you may say that you saw nothing, but your behavior might still be influenced by what you see. Psychologists call this priming. And that's interesting because if I flash the image for a little bit longer, then maybe you will consciously see the image. And here then there's an opportunity because we can compare both what's happening in the brain between these two situations, either you consciously see it or you don't, and we can compare what people can do in these two situations too. So what's the benefit, what's the functional advantage that conscious perception as opposed to unconscious perception gives you?
And you point this out in your book, that there's a lot of communication going on between the brain and the organs and various parts of our body that we're not really directly conscious about, but somehow they lead to a conscious experience.
That's exactly right. Yeah, but I think in a sense it's almost more interesting the other way around, because when we open our eyes and we look at the world, it seems as though we're having a quite direct experience of what's out there, right? That my experience of this mug that I'm drinking tea from is a very, very closely related to objective reality. This mug has a particular way of reflecting light and so on. So our phenomenology, the way we experience things in vision and in hearing and so on, seems to be quite direct. But I think that's part of the grand illusion, if you like, about consciousness, which has been known in other traditions for a long time. The Hindus call it Maya and so on, that the world of appearance is not the same thing as the world of reality. And this is very, very clear when it comes to the body, because yes, you're absolutely right that from the brain's perspective, the organs, the interior of the body, it also has to be guessed at, right? The brain doesn't have any direct access to the heart or the liver or the lungs, just as it has no direct access to what's on the desk in front of me. It has to make and update predictions. But now what we experience when the brain does this is not, my liver being a particular shape and in a particular location in the body. The overall thing that I might experience as a result of the brain making predictions about the body is something like emotion. I might feel happy or sad or anxious or afraid, or that seems to be the experiential flip side of these kinds of predictions. So it's kind of obviously indirect in that sense, and reasonably so, because it's not useful for us. It's not a useful thing to experience where the liver is, right? In the same way that we don't need to experience the fact that we have neurons. The functional role here is to understand the overall physiological condition of the body, how well it's likely to do at staying alive in the future. And so experiencing things in the dimensions of emotions is much more reasonable. But both seeing the cup in front of me and experiencing mild anxiety or whatever it might be, both are, I would say, maybe not equally indirect, but they have an essential indirectness about them.
I want to talk about something you mentioned that in your TED Talk that gave me a chuckle and gave the audience a chuckle as well. You described, the fact that what the brain engages in is controlled hallucinations, and that's a great word to be using these days, given the prevalence of LLMs. So, but in your book, you used it way before it's become quote unquote popular now. And I like the fact that you said your definition of reality is hallucinations that we agree on.
Yeah, the first thing is it's funny and interesting that you pick up on this in the context of things like large language models, where of course you're absolutely right that people regularly talk about them as hallucinating. I've actually been trying to push back against that usage. Because I think it's highly misleading. When we talk about a hallucination, if I was to say, I think you're hallucinating, I don't mean that you're saying nonsense things. What I usually mean, if I say you're hallucinating, I'm saying that you're experiencing something that isn't there. You're hearing a voice or seeing something that's not there. That's the main colloquial meaning of hallucination. So when we say that language models hallucinate, I think this is really unfortunate, because it implicitly implies that language models have experiences, that they are in some sense conscious. And of course, we might come to this later, but I think this is really almost certainly not the case, and people are thinking very unclearly about these things. So I much prefer to say that language models confabulate rather than hallucinate, because when we say a human confabulates, they make stuff up.
I agree. In fact, I think people use it synonymously with they make mistakes. That's kind of how they're really using it, as opposed to the way in which we think about it, which is that you're imagining something or you're distorting something,
yes,
so badly that you're, again, sort of imagining it, through distortion.
Yes. No, that's right. And of course, the words we use matter. As it has been, the language of machines hallucinating has become rather normalized now. So it really does just encourage us to think that, machines perceive things, they experience things. And I think that's an unwarranted inference. But applied to us, I think it is a useful word. And the term controlled hallucination is, again, something I borrowed, stole, adapted from other people. It's been around for a while. But I found it particularly useful because, to me, it underlines the central point that what we experience is not an objective, passive registration of reality as it is, but an active, top-down, inside-out construction. And hallucinations, of course, have that character too. When we talk about hallucinations, normally we think of them as experiences that are detached from the real world, that come from the inside out. But the controlled part of controlled hallucination is equally important, and it's why there's a difference between hallucination and normal perception. In the normal case, our perceptual constructions, our brain-based best guesses, are controlled by, calibrated by, reined in by objective reality in ways that are useful for us. So that's why I use the word controlled hallucination. And when the control starts to slip, well, that's when we actually hallucinate. So you could, by the same token, you could say a hallucination is a kind of uncontrolled perception.
Right. So let's come back to consciousness and whether you need biology to have a conscious experience. My sort of reading of your book is that you do, that it's closely tied to the very idea of living and surviving, as you mentioned, right? The goal is to survive and maintain stasis, maintain these states of the world that let us live, which are sort of, counter to sort of the second law of thermodynamics, which says that everything descends into disorder. So life is really about order. And consciousness, in your view, derives from being alive, from living. So is biology necessary for consciousness? And I'm inferring that it is, but you tell me.
I think it's a good inference. I think it is. I mean, I can't say that it's possible to demonstrate that. It's not a conjecture that has reached the level of being a testable or refutable hypothesis. But it's something that I find usefully organizes my thinking about this and to me makes a lot of sense. And there are a number of reasons why I find an intimate dependence of consciousness on biological systems appealing. One is that it's a simple observation that all the things that most people agree on as being conscious are living things. It's just like, well, there are humans, there are other animals. Those are the only things that most people would say, yeah, we're pretty sure that they're conscious. There are plenty of things that do depend uncontroversially on our biology, things like digestion or metabolism. So why not consciousness? Well, I think you need to say a bit more, but that's a starting point. Another angle onto this is really pushing back on what has been, and I think remains, the dominant alternative, which is the idea that consciousness is a matter of computation. That it doesn't really matter that brains are made out of squishy wet stuff. All that matters is that they implement certain computations, certain forms of information processing, and anything that implements the right kind of computations, whether it's GPT-5 or some other computer, that would be sufficient for consciousness. This is a really dominant assumption. It's called computational functionalism. I've been unhappy with this assumption for a long time, and the short reason why is that I don't think the brain is a computer. I think we've taken the metaphor of the brain as being a computer and made the mistake collectively of confusing the metaphor with the thing itself. And we always get into trouble when we do that. We can use computers to model the brain. Some of the things brains do might count as computation, but consciousness is unlikely to be one of them. So I think there's a pushback against the idea of the brain as a computer. And then there's something more positive we can say, which comes right back to this idea of perception and controlled hallucination. And here, if we started with this idea that our perceptions of the self and the world are kinds of perceptual predictions, these brain-based best guesses that are continually updated by sensory signals. And what I try to do in the book is just pull on this thread as long as possible and see where it leads. And for me, where it leads is this idea that this process of brain-based best guessing is fundamentally, when it comes to the body, it's about keeping the body alive. It's about control and regulation. When you can predict, you can control. And that imperative to stay alive goes right down even into individual cells and into the furnaces of metabolic activity. There's a strong parallel between how we think about the brain minimizing sort of a kind of informational prediction error when it's making perceptual inferences about the world, and how it's minimizing some kind of thermodynamic prediction error or free energy when it's trying to maintain itself in this state of being alive. So I find this whole idea of the brain as a prediction machine is continuous, deeply continuous with our nature as living systems.
I mean, I can see your argument, that is that as far as we know, as you know, if you look around us, consciousness seems to be associated with living things. But why does it have to be? I mean, are you defining it that way, or is there a fundamental property of consciousness?
No, I mean, it's a right to push back on. I think if you define it that way, then, nobody emerges any the wiser, right? You're just doing something by fiat, by definition, and nothing is gained. No, I think I meant it simply as just an observation that, you could have sort of two starting assumptions. One is that consciousness is a matter of computation. That has some surface appeal because it means, okay, we look at what a system can do, not what it's made of, and maybe what a system can do is more important. And you can generalize. So that has some surface appeal. But then so does the idea that consciousness is fundamentally biological, because that characterizes the landscape as we know it. But I certainly wouldn't want to define it that way. It's just an observational starting point. And you can imagine, okay, let's just take both as equally likely. We just have a completely open mind as regards whether computation matters or whether life matters. Of course, there are other options too. I mean, these aren't the only two options on the table, but for now, let's think of it that way. So certainly not doing it by definition, but just want to approach it with an open mind and then say, okay, what are the reasons we might favor one or the other? And for me, the more I look at it, the reasons for favoring the computational view seem to be on increasingly shaky ground, because the more you look at the brain, the less it looks like the sort of thing that is a computer, and the less the things that it does look computational. And then on the other side, there seem to be increasingly compelling positive reasons to understand that the things that brains do and the phenomenology, the nature of a conscious experience itself, to be intricately embedded in the biological nature of brains, and not something that sort of skates in some abstract information processing realm, and the brain is just some way of implementing some information processing that could equally be done with some tin cans and string if you had enough of them.
Let me continue on those lines. I don't mean to disagree, but I'm just playing devil's advocate. Because,
no, please disagree.
Because it reminds me of a story, Steven Pinker, I think it was in his book called How the Mind Works. So he talks about, he says, that there's this sort of a prior that we have, that intelligence, and by the way, now I'm switching to intelligence. I'm going to come back to sort of intelligence versus consciousness as well, where he talks about, an alien species descends on the planet and it's silicon-based. The head of the delegation sort of observes what's going on and radios back and says, "Hey, Chief, there's this species here that's biological and they're really impressive. They've done amazing things." And this goes on for a while. And his boss from Planet X says, what, like sentient meat? That's unthinkable. Eh? And of course, Pinker's trying to make the point that people find unthinkable that computers could be, I guess, for a lot of my career, by the way, I encountered pushback that they could even be intelligent, and some people still question that. But certainly people would say they're not sentient. Some people would claim that this is sort of a bias that we have, that we associate intelligence and consciousness with biology, but there's no reason that the underlying substrate couldn't be something else.
Well, yes and no, I think. I mean, I like there's this idea of sentient meat. I think there's another short story, I forget the author, about there's a phrase, they're made out of meat, and that becomes one of the the main things, like about how is it that meat can possibly do all these things. I mean, you're at NYU, aren't you? And one of my philosophers called Ned Block, who's also there, who I admire very much, he makes a similar case to me, for why meat matters. Now, I think the force of that argument is to point out that we shouldn't be unjustifiably chauvinistic one way or the other. Like, we shouldn't be carbon chauvinist and say, no, of course, only carbon-based meaty stuff can be A, intelligent, or B, conscious. We've got to come up with better arguments in either direction. And here's where I think the distinction between intelligence and consciousness is really, really important. And the reason is that intelligence is, by most reasonable definitions, intelligence by most reasonable definitions is about what a system can do. It's about its functional capabilities to do things, to transform inputs into outputs in some way, behave in some way. That's what intelligence is very broadly involved with. And so in that sense, it does seem like there will be a bit more flexibility about what kinds of things can exhibit intelligence. Computers can certainly exhibit a kind of intelligence. I think is an open question still whether they can exhibit human-like or biological intelligence in all its ways, but they can certainly do things that we would call intelligent, and they do them in different ways. So I think that's totally fine. I totally accept that AI is in some forms possible. It's already here in some forms. But consciousness is a different thing. It's not defined in general in terms of what a system does. It's more about being than doing. There's an experiential aspect, an essentially subjective aspect to consciousness. And to make the claim...
And is that feeling?
Yeah, well, I think it depends what you mean by feeling. I mean, Thomas Nagel, whose definition of consciousness I still go back to, says things like, for a conscious system, it feels there is something it is like to be that system. It feels like something to be me or you. Feeling doesn't have to be valence related here. It doesn't have to feel good or bad. But yes, it feels like something, which is I take as synonymous with saying that for that system, there is experiencing happening. It has an inside as well as an outside. It has a subjective existence as well as an object-like existence, an extrinsic existence. And it's much harder, at least I think it, and it ought to be harder to extract consciousness from a system where we know it's happening and say, okay, you could do it in another way, in another system. Fundamentally, because consciousness is not, on this definition, about what you do. I mean, there are some theories which will say that of course it is, and those theories would say, yes, if you define consciousness in terms of what a system does, then it becomes more conceivable that other kinds of things could do it in the same way that other kinds of things can, in quotes, do intelligence. But that's a controversial definition of consciousness. And if consciousness is fundamentally about being rather than doing, about having experiences rather than performing functions, then it's much less clear that anything goes, that you could have conscious computers or conscious tin cans or conscious tables or whatever.
So does the alternative definition, I guess the functionalist definition, assume that as long as it can do the kinds of things we associate with consciousness, it is conscious?
Sort of, yeah. So the functionalist view would say that consciousness is a property of the functional organization of a system. And this is not the same as saying what consciousness does for us as conscious creatures. Like, consciousness might do lots of things for each of us. It might allow us to behave in particular ways, bring together a lot of information about the world in a way that's centered on our bodies and survival prospects. So consciousness could have a function, but its basis might not be functional at all. It might be something that's completely dependent on what something is made of. So these two things are different. But let's accept, for the sake of argument, let's just say something like functionalism is true. So consciousness is a property of the functional organization of a system, not what it is made out of. Now, the problem here for brains is that it might be in principle impossible to separate what brains can do, their functional organization, from what they are. In great contrast to computers. Computers have been designed and are engineered specifically so that you can separate what they do from what they are. You can run the same code on different computers, they do the same thing. You can run different programs on the same computer, and they do different things. There's a sharp, by design, clear air, bright line between hardware and software in modern computers. In the brain, there is no such thing. There is no such separation between mindware and wetware. You cannot separate what brains do from what they are. And this, to me, really undermines the idea that even if functionalism is true, it's not clear that you could get the same functions or the same functional organization without actually having a brain. It might not be portable to a computer.
And how do you think of sort of this metaphor of the brain as an information processor, right? Because you said, well, it's not a computer, but at the same time, it is an information processor, right? So it is sort of working with information, even though it may not be aware of it.
Sort of, but I think we have to be very careful here. This language of the brain as processing information has been very, very normalized. In fact, I'm sure I've used it in many of my own papers. But it's just kind of a loose shorthand for the brain doing stuff that we don't quite understand. If we think about what it means to say that something processes information, what do we really mean? I mean, information to who, to what? What gives semantics to the syntax? Information theory from Shannon is really just a way of doing statistics of some sort, to say, how much statistical structure in A is also in B and these kinds of things. It's the external observer that gives the meaning to the signals that we say have a particular entropy or information content or something like that. So I think it may not be true that the brain processes information. It may be the brain does stuff, and we use the language of information processing or information theory more generally to try to model what the brain is doing, to try to understand it. But it's a different question as to whether the brain itself strictly processes information. It might do for some things, but it might not do this in general all the time.
Let's address whether consciousness is possible in AI, whether AI can be conscious, right? So my colleague Dave Chalmers, who was a guest on the podcast a couple of years ago, I've heard him recently say, well, AI could become conscious. And I'm not quite sure what he means, but maybe you can elaborate on that as, your book is a lot about neuroscience and philosophy and other areas sort of brought together. How would you interpret what he means when he says AI could be conscious? And I know that your position is that, at least the way it is now, that it can't be.
Well, I think it's unlikely. I think it's impossible to be definitive, right? Because to be definitive, we'd need to know for sure what the sufficient and necessary conditions are. And I just don't think we do. But I think it's unlikely. I've had a lot of conversations with Dave about this. I think last year, actually, we were both at the World Science Festival in New York on a panel discussion with Brian Greene on exactly this question. And I don't know if his views have much changed since then. But and I don't really want to speak for him, but certainly we had a friendly disagreement about this. I think he was of the view that it's indeed possible, if not quite likely, that some forms of AI would be conscious and not merely intelligent. And yeah, I have to say, I take a different position. It's not that I think it's totally impossible, but I think there are many reasons which will lead us to overestimate the likelihood of AI being conscious. And one of them is that we sometimes confuse intelligence and consciousness, and because they go together in us, we think they go together constitutively. And so as AI gets smarter, we become more tempted to ascribe consciousness to it, but conceptually they're actually quite different. And it may very well be that AI can become intelligent, but without being remotely conscious. And I think language models are a good example of that. They have a form of language. Maybe it's even a very impoverished form of human language, but they have a property that we normally associate with consciousness. So we're very drawn to project consciousness into language models based on that similarity. And I always note that almost nobody thinks that DeepMind's AlphaFold program is conscious. The AI system that was recognized by the Nobel Prize last year for solving the protein folding problem. It's basically the same thing. Obviously it's not exactly the same thing as a language model, but it's really not that different under the hood. Yet it doesn't speak to us, so we don't imbue it with these properties. So I think we have to be very aware of our psychological biases. And then there's this whole debate we've been having, and here's the heart of the discussion that Dave and I have been having for a long time now, which is computation sufficient? Perhaps if you simulated the brain in every last detail, surely that would be enough for consciousness to emerge, would be one argument. And again, I'm not saying that's his argument, but this is the debate we've been having. And yeah, I come down differently. I think there are all sorts of reasons why it's a big assumption that computation is sufficient for consciousness. It may be, but it really may not be. And if it isn't, then AI as it is now won't be conscious. Doesn't mean that conscious AI is impossible in principle. The question then becomes, how brain-like does AI have to be to move the needle on the possibility for real artificial consciousness? Do you need sort of neuromorphic computers that are brain-like in some relatively small ways, or do you need to go the whole hog and have systems that are actually biological, made out of real neurons? I think that's an open question.
It's a fascinating question, right? Is computation sufficient? Because when I was thinking about it, I was wondering if it assumes anything about the sensors that are giving you the information that, is responsible for consciousness, right? So, you talk about the fact that bodies, a brain sort of communicating with the rest of the body, it feels a certain way because there's stuff going on. There's organs doing their thing. There's blood flowing. There's sensation. There's all these sensors that are feeding back. And so when I think about this question about is computation sufficient, I guess my follow-up question to that is sufficient given what? It's like, what's the input into the computation, right? If the input includes all the things that we normally associate with consciousness, then why wouldn't it be consciousness? I realize it's a real stretch to imagine computers having the same kind of sensory, paraphernalia that living things do. But if they did, then maybe they could feel things.
Yeah. I mean, I think it's an interesting point it's an interesting scenario to explore in sort of a region of this whole conceptual landscape, because it's also not totally implausible, right? Because at the moment, things like language models are very disembodied, but there's no reason And people are already doing this. Why not put them in a robot? Why not give them sensors to interact with the world? Why not give them a battery level and some sort of sensation of how much energy they have left, so they have some sort of internal homeostasis to worry about too? So you can bring in more factors and then ask, so what difference, if any, does that make, and why? And I think doing this actually leads to some interesting ideas. For me, one of the really provocative things that comes of this is it's related to another debate about language models, which is not whether they're conscious, but do they actually understand anything? They come out with all these utterances. And for us, human beings, we put these two things together normally. We think of consciousness and understanding as being possibly inextricable. But maybe future language models could be actually said to understand without us having to ascribe consciousness to them. And this may be the difference that embodiment and embeddedness in the environment make. The reason why, or one reason we think language models don't understand anything at the moment is because the tokens, the symbols that they manipulate are just abstract, right? They're not grounded in real world interactions, whether during the training or even during the inference when they're generating responses. And there are many, I think, quite compelling theories in cognitive science that suggest that for tokens or symbols to gain meaning, they have to be grounded in physical interactions with a world and a body. And this has always been known as the symbol grounding problem from Stevan Harnard onwards. So here's an interesting scenario, that if you have a future language model that is not only kind of implanted in a robot, but actually maybe trained with data that is coming from being embedded in a world where it can interact with the world and generate its own data in response. Perhaps here you have a situation where indeed this language model truly understands what it eventually says, but without any subjective experience whatsoever.
Yeah, great point. So, one of the parts of your book that also fascinated me was your discussion of animals, like animal consciousness. I was also struck by your description of octopi. And, I had
octopuses. I've been told. Is
that real? Is that true?
I think so. I think okay. the correct plural is. I think apparently octopi is a bit of a tautology. It's like eight or something. So,
okay.
So it's octopuses.
All right, I stand corrected. So you talk about octopuses, and one of my previous guests was Pippa Ehrlich, who was the producer of my octopus teacher.
Oh wow!
And I was just blown away by that film. And, there's no way I can eat octopus, anymore. It just seemed like an incredibly sentient being. Your position is that animals do have consciousness. It just varies by type and degree. Is that fair?
Yeah, I think again, leavened with a little bit of epistemic humility and uncertainty, we don't know. The further we get away from the human example, the less we can be sure about things, because we don't have a consensus theory of the sufficient and necessary conditions. But I think historically we have, at least in the Western tradition, we've tended to underestimate the distribution of consciousness. And we've tended to do that maybe for precisely the same reasons that we tend to overestimate the likelihood of language models being conscious, which is that we take what we think of as distinctively human things as being markers of consciousness. So we take language and cognitive sophistication as being reliable indicators of consciousness. And that means we're more inclined to give them to language models, and we're less inclined to give consciousness to things that don't live up to these questionable human standards of cognitive competence. But I think, it would be once you factor out these biases that we have, and then you just look at, okay, which is most likely to be conscious, a language model running on a computer or an octopus? And you look at, well, what's shared between us and these systems? So much more is shared in the octopus case, even though our common ancestor goes back however many 100 million years. And if you look at what octopuses do and how they do them, you can sort of see that the sorts of things they do are the sorts of things we associate with consciousness in human beings to some extent. They learn very quickly. They adapt flexibly to novel situations. They do all these kinds of things. So, yes, I have no doubt that other mammals are conscious. Their brain architecture is very similar to ours in the ways that seem to matter for consciousness in humans, and their brains are sufficiently similar so that we can do these direct comparisons. In fact, a lot of what we think we know about human consciousness, of course, comes from studying other primates and other mammals, whether it's monkeys or mice. But as we go further away, our inferences become less secure. And octopuses are a great test case because they are so evolutionarily distant from us, yet they are complex creatures. They have tons of neurons. They do interesting things. Do they do all these things unconsciously? Again, we don't want to fall into the error of only considering octopuses because they seem intelligent. That would be smuggling some of our psychological biases back in through the door again. But all things being equal, maybe that makes octopuses an interesting place to look. For me, I start to get very uncertain when we talk about insects and certain kinds of fish and simple creatures like paramecium and nematodes and all of these kinds of things. There, I have very little intuition about whether these animals are conscious or not.
I was surprised that octopuses are colorblind, considering how much the role of color in their lives, right? The fact that they can't perceive color and yet they're doing all these kinds of things to react.
It's amazing, isn't it? I mean, they can change the color patterns on their skin to create camouflage or threat displays or all these kinds of things. But yeah, they don't seem to need to sense color through their eyes to do that. I mean, octopuses can see with their skin to the extent that matters. And so there are these incredible differences, which I think to me, this is in a sense the more interesting question. Not is it conscious or not? I mean, okay, I think we should continue to ask that question, but the likelihood is yes in some way. The more interesting question is, well, what would their experience be like? And this is interesting not just in a sort of zoological perspective about, okay, what is it like to be an octopus? What is it like to be a bat? But because of how it refracts back onto our own conception of what it's like to be a human. And I think by making some claims or investigating what it might be like to be another animal, we realize that the human conscious experience is just one small region in a vast space of possible ways of experiencing the world. I think Ed Yong's recent book, The Immense World, is beautiful on this, on how this old idea of the Umwelt, the lived sensory environment of a creature might be so different from one animal to another.
Yeah. I mean, humans, I guess some people call it speciesism, that we are speciest. I mean, like racism, like speciesism. And there's a really amusing book by R.K. Narayan. I think it's called A Tiger for Malgudi, which is a story about a tiger that understands humans' language and is conscious. And it's a really amusing story about what it thinks about what humans are saying about it, and how it, quote unquote, talks about the fact that it seems so self-assured without knowing that much.
Well, one of the really fascinating applications of machine learning that's happening now is all these projects that aim to decode animal communication and, raise the prospect of that situation being real. Maybe we'll be able to decode what a tiger is really thinking or what an octopus is really thinking. Maybe not an octopus, but I find this absolutely fascinating and actually fraught with a lot of ethical worries too. How can we be sure of being accurate? How will this change how we treat other animals? We might become speciesist in a different way, right? If we might only care about animals that have something interesting to say.
Yeah. True. By the way, one of the other things that surprised me was that monkeys don't pass the mirror test.
Right.
I thought for sure they would recognize themselves in a mirror. So that one really surprised me.
Yeah. This mirror test, this ability to recognize that a mirror image is you, is actually fairly rare throughout other animals. Elephants seem to be able to do it, or at least a couple of examples, some primates. But yeah, most monkeys, I think, or all monkeys, can't. And again, to me, that just brings home, like, okay, there are things that seem so obvious about my experience of the world that when I see a mirror image, I don't have to think about it. It's just me, clearly. And that is so deeply embedded in the human experience of the world and the self that it's hard to imagine what it would be like to not have that. Yet we are the exception rather than the rule.
So Anil, before we wrap up, I just want to ask you about how you think about free will. You talk about it in your book. I had someone talk about, Kevin Mitchell talk about it, and he's of the view that it exists, but of course I think the majority is that it doesn't, which I find really surprising, to be honest. How do you think about it?
I share that surprise, but I think it all depends on what you mean by all the words. Like, what do you mean by free will and have and I? All of these things become very important in this, because I think a lot of the debate, in my mind, turns on whether we have or don't have a version of free will that we shouldn't even be discussing, that just doesn't even make sense. Kevin, I know, I'm actually be discussing this topic with Kevin here in Brighton at the beginning of April. I'm looking forward to it. I enjoyed his book as well, Free Agents, so it's really good. What I have to say, this chapter in my book was both the hardest to write chapter for me of any of the book, partly because I hadn't written about free will before, but it's also the chapter I'm hesitant to say this, but I'm most proud of in the whole book. It was like, oh yeah, now I feel, now I've written it, I think, yes, now that makes sense. And it's a struggle to explain how and why, because it's deeply embedded in the rest of the book. But briefly, in discussions about free will, they're often posed in a pretty stark set of choices. Either we have it, and there's something about consciousness that allows a conscious human being to change the course of physical events, to make things happen that wouldn't otherwise happen. So we have free will. Or we don't have it, and the world is just sort of chugging along its deterministic tram lines, maybe with a bit of randomness. And the feeling that we change the future is just an illusion. So it's usually framed in those kinds of terms, right? And Robert Sapolsky, for instance, goes completely on the determinist side of things. Now, I find myself more at ease with what's often called a compatibilist position, which is the idea that there are forms of free will, or there's at least one form of free will, which is compatible with the universe being deterministic. And this is a position, Daniel Dennett sort of held this position as well, but it can be unpacked in various ways. And the way I unpack it is really a continuation of the whole idea of every conscious experience being a form of perception. And what I think is going on in a very compressed description is that when we experience free will, when we experience this urge to do something, or the feeling of agency of having made something happen, that's the sort of experiential flip side of the brain's inferring the causes of an action that the body made. It's a bit like, again, when we were talking about how when we experience an emotion, that's the experiential flip side of the brain making a prediction about the physiological condition of the body. But in this case, the brain is always trying to infer what caused the actions that the body makes. These inferences about the causes of actions are actually the causes too. So there's a sort of dual role here. When the brain is inferring that it's done something, that's playing a causal role in that thing happening. But that explains for me why experiences of free will have the character that they have. They have generally three things. We experience a freely willed action as coming from within, as being aligned with our beliefs and desires, and we have this feeling that we could have done otherwise, this counterfactual potential. But just as when we see a red mug on the table, it doesn't mean that the mug is actually red. It's there's an indirect relationship. just because we experience an action that we could have done otherwise doesn't mean we actually could have done otherwise. I don't think we could have done otherwise. The utility of experiencing things this way is, I think it's a way of learning. So the brain changes every time it does something, perceives something, it changes a bit. So the reason that we perceive some actions as freely willed, I think, is so that the brain is able to evaluate the consequences and maybe do something different the next time.
So how is this compatible with the deterministic view?
We're not relying on any kind of supernatural, spooky intervention into the flow of events at the level of atoms or anything like that. All of this stuff could chug along completely deterministically, but it would still explain the phenomenology of free will, and it would preserve a sense because the brain changes and it literally does do something different the next time. Maybe it was determined to do that. Maybe it was random. Who cares? It's compatible in that sense. Now, there's a lot more to say here about how, whether it makes sense to say that you can have high-level causes or whether everything is just atoms and the void. And I think with Kevin here, and this is a point that we agree on, and I've done also, this is not so much in the book, but in my lab, we've done a lot of work on emergence and what does it mean to say that you can have an emergent property in the brain. In much the same way, you can say, a flock of birds is an emergent property. It has an identity and autonomy that's more than the sum of its parts. And I think there are ways to talk about that reasonably. And then you can ask the question, do you have higher level causes? And I think, again, you can say yes to that question in a way that's still compatible with determinism. It doesn't mean determinism is true. I don't know whether determinism is true. It may be, it may not be. The point is, I think any explanation of free will that relies on it either being true or not being true is fundamentally mistaken, because either it's saying, our experiences of free will are meaningless, or it's saying the answer is in random activity, and that neither of these options to me is satisfactory. I want to try and make sense of experiences of free will on their own terms.
Good stuff, Anil. Really enjoyed the conversation. Before we go, what have been, in your career, some of the experiments that you would regard as being sort of the most mind-blowing, that revealed something really interesting?
Well, I'll tell you one which just flows. And it comes to mind because we were just talking about free will. And it's an experiment by a neuroscientist called Schurger. And it's now over 10 years old. I think it was published in 2012. And it's an experiment about the brain basis of voluntary action. Now, there's a classic set of studies about free will done by a guy called Benjamin Libett in the 1980s. And these are often interpreted to show that free will doesn't exist. And what he did, very briefly, he was very clever experiments too, fantastic experiments. What he did was he got people to make simple voluntary actions, like press a button when you feel like it. And then he measured the time of the button press. He measured what happens in the brain in the lead up to the button press. And critically, he measured when people felt the conscious urge, if you like, the moment of free will to push the button. And what he found, and this has been replicated many times, is that you have the button press at time t, and then of course before that you see brain activity beginning to ramp up over particular parts of the brain, like the motor cortex and premotor areas and things, before the button is pushed. But the moment of the urge to move happens after the brain already seems to be preparing for the movement. So that looks like the brain's already gearing up to make the movement, and then once it's almost ready, then you have this like, I want to press the button. So the interpretation for this for a long time was, the brain knows what you're going to do before you do it, no free will. And even Libett thought this too, and he tried to say, well, maybe there's still space for free won't. Maybe you can get in there in the little bit of time that remains after the urge and stop. Anyway, then you get another set of problems. So what Schurger did, which was very, very cool, was to just make an observation that, like, hold on, this is a really weird experiment because you're looking only at the times where people made the action, and you're not looking at all the other times where they didn't make the action. And maybe this ramping activity, which is called the readiness potential, and it's been known about for decades. Maybe that isn't the preparatory activity for this specific action. It's just some sort of random fluctuation in the brain. And if you only look at those places where the action was made, and then you look back, it will always look as if this activity is ramping up. But that's because you're selectively sampling. And so what he did to experimentally test this idea was he kind of compared situations where people made completely unprompted actions, like in the Libett experiment, but also other trials where people made prompted actions, like press the button now, so not free will. And what he found was that if you looked at how quickly people pressed the buttons in those situations, and then looked backwards in time to see if there was anything like a readiness potential, when people pressed the button quickly, it looked like there was a readiness potential. So that just meant the brain, this internal fluctuation in the brain had sort of nearly reached this threshold. So when you look back, it looks like it's there. But it's completely an artifact of how you sample the brain activity. And I love this study because it's very simple, it's very imaginative, it's very rigorous, and it throws a whole bunch of confusion and misunderstanding of free will right under the bus.
Very cool. In fact, this phenomenon occurs so often where we have a selection bias and we only choose to look under the lamppost because that's where the light is.
And just to bring us back to an earlier part of our conversation, I think that is exactly what is happening when people assume that computation is sufficient for consciousness. We're so used to thinking about the brain computationally. Computational models are super powerful. We have all these neural networks that do clever things. We are looking for we're looking for the car keys of consciousness underneath the lamppost of computational functionalism.
Anil, on that note, I want to thank you. I've really enjoyed this conversation, enjoyed reading your book, really good stuff, and hope to catch up in person one of these days.
I would love that. I've enjoyed it very much too. Thank you again for bringing me on.
Thanks so much.
Really appreciate it.